I see still people are joining in.
Yes,
Okay, the more the merrier.
yes. That's why I. So, I think we should be starting now. So, welcome everybody. Hello everybody joining us from Egypt and around the world, I can tell now. I would like to say just a couple of words in Arabic and then get back to English so we can resume our presentation. So مساء الخير جميعا، برحب بكم في أولى ندوات سلسلة البنية الأساسية الرقمية التي تعقدها جمعية إنترنت مصر، والتي طبعا تمثل فرع جمعية إنترنت الدولية إنترنت سوسايتي. أنا مريم فايز أمين عام الجمعية وبرحب بكم. طبعا احنا بنشكر زميلتنا هنا على إنها ساعدتنا في إن احنا نفاسيليتيت أو نجهز للندوة النهارده. أستأذن حضراتكم في بعض القواعد الأساسية إن احنا نبقى على وضع الصامت طول الوقت أو ميوت، ونكتب أي أسئلة في الشات، وإن شاء الله هنفتح الحوار في النص الثاني من الندوة. والندوة طبعا هتكون باللغة الإنجليزية. وندوتنا اليوم طبعا زي ما قلنا البنية التحتية الرقمية ونظرة عامة على هذه الصناعة والتوجه. وبشكركم طبعا، وزميلنا وصديق عزيز لمجموعة إنترنت مصر طبعا المهندس أحمد عبد اللطيف، خبير الدولي في قطاع الاتصالات وتكنولوجيا المعلومات، هو اللي هيكون بيحاضرنا النهارده. أنا هنقل للإنجليزي وهحط طبعا لو تسمحوا لي السيرة الذاتية بتاعته في الشات عشان ما ناخدش من وقت المحاضرة. Good evening again, Cairo time. I'm Mariam Faiz, Secretary General of Internet Masr, ISOC Egypt chapter. On behalf of Internet Masr Association Board and Chair, I would like to welcome you to today's meeting. It is the first session of a series that's upcoming on the digital infrastructure. Allow me to thank Hannah Sabah, our community manager for Middle East and Africa in ISOC, who facilitated the happening of the conferencing means for this session. To our participants, I thank you in advance. We thank you for participating in this webinar and your interest in the topic. Today, we're going to get an industry overview about digital infrastructure and its impact in shaping economies. I hope this meeting is the start of a productive conversation. Our speaker today, Engineer Ahmed Abdel-Latif, is a recognized international telecom technology services executive with unique expertise in international B2B digital infrastructure and wholesale business across the Middle East, Africa, Southeast Asian markets. Over a career spanning 28 years, Ahmed served in global institutions, including MCI, Verizon, Global Cloud, Exchange, Etisalat Group, Batelco Group. He holds a bachelor's degree in telecommunications and electronics engineering from Ain Shams University, Cairo, Egypt. Also a master's degree in computer science from the University of Louisville, Kentucky, USA. And a master's degree in business administration from Maastricht School of Management in the Netherlands. Thank you, Ahmed, dearly for sharing your expertise and supporting Internet Masr. But before I hand over to Ahmed to lead the webinar, allow me to mention a couple of house rules. Please keep your mics muted till the discussion starts in the second half of the webinar. Register in the chat so we get to know you better. Feel free to post your comments and questions in the chat as well. And finally, this meeting is recorded. Over to you, Ahmed.
Thank you. I hope everybody can hear me clearly and see the opening slide. Again, I have no request other than to just to reiterate what Ms. Mariam said. Just keep your mics on mute so that we can have a productive session. I can promise you at the end we're going to have enough time for Q&A. Hopefully we'll cover as much as possible. If not, we'll make sure to follow up via written format somehow to address your questions. Today I have a very simple mission. I'm going to tease you. I'm not going to give you anything that is definitive or final. My job today is, for lack of a better analogy, is like those people running around with trays at cocktail receptions. They claim to give you food, but they really give you nothing. These tiny pieces of shrimp or cucumber or cheese, whatever, do not really satisfy your hunger. So today, if you came hungry, I promise you leave hungry. The idea here is to open the door for more sessions and more discussions that address specific parts of the digital infrastructure landscape. So my job today is just to tease you as much as possible. Hopefully I will be successful so that you come back for more sessions. And more people from the Internet Society of Egypt will be able to pitch in as well and add their respective expertise, which is a lot, I can tell you. And it's really an honor to be among such a group of luminaries. My opening slide is going to be a number. It's always nice to start a presentation with a number. So essentially, just to set some background, this is a statistic about the digital economy, and this comes from the World Economic Forum, which is definitely a trusted source of information. And the number here is staggering. The digital economy as of 2021 amounts to $14.5 trillion. So naturally, we are all curious about how this digital economy, functions, how this digital value gets created, where it gets stored, where it gets transmitted, and what kind of issues in terms of politics, national geopolitical pressures, and so on surrounds this. So that's what we want to actually open the door to discuss. Hello. Still here? Okay. So this is another interesting statistic about the growth of data. We all use data across the board. We use it in our sort of laptops, mobiles, tablets, smart devices, and so on. And this is an interesting statistic just to put things in context. Most of us here were around when the internet got created, 1995, 1998. And we still remember those late night dial-up sessions. We have come a long way. So this statistic essentially shows that the rate at which data grows is phenomenal and is going to actually get much faster now that we have machines creating data, not only humans. What is interesting to note is that up until 2023, only people generated data. Now with AI agents and AI systems, we have machines generating data. So anything that you can look at your screen right now in terms of data growth is nothing compared to what's going to actually be happening in the next 10, 15 years, which is a fantastic statistic if you are in that business, and hopefully all of us are in that business in various capacities. This is not something new. Data connectivity has become the fourth utility in a modern home. It used to be sanitation, water, gas, and electricity. Data connectivity now is part of our society. Now, why is this important? Because one of the things I'm going to shatter today is that this whole thing about digital and data and everything is a telco business. It's not. It's too important to be left to telcos. The landscape of digital infrastructure now covers many stakeholders and many players. So mentally, I just want you to accept the fact that what used to be a very professional telco service is now offered by a number of stakeholders and a number of entities. And this is good. This is not necessarily bad. It means that telco's role in enabling this is fundamental, but they are not necessarily the only entity that actually has to worry about how these services are developed, how investments are made, and how this data gets carried around across national borders and so on. This is going to become clear in this slide. We can argue about the dates in this slide. I mean, you can never establish a clear-cut date about any of these things, but I just want to highlight that we have gone through 3 waves and now we're starting the 4th wave. So there was a wave of telecom, whereby we got introduced the whole notion of mobility, data services on mobile, and so on. This lasted around 10 years. Some would say 15, some would say 12, doesn't really matter. Then came the notion of ICT. This was the first time we started hearing about these global platforms and applications having interconnection capability and data crossing from one system to another. And of course, mobile continued and telecom continued to be an enabler, but the focus was more on ICT to figure out what can we do now that we have this global connectivity fabric. Then came the digital wave, which for good or for worse, obliterated and eliminated terms like ICT. I was having a chat last week with somebody who reminded me also of another term, TMT, technology, media, and telecom. All those terms are fading now into history. The key word now is digital, because we have everything interconnected. All the devices, all the networks, all the global computing platforms are somehow accessible, regardless of location, regardless of distance, and so on. And then we have the dinosaur that is just awakening, which is the AI wave. And these are opportunities. Do not look at these as things that are necessarily bad or replacing industries or destroying value. Look at them as opportunities. The digital opportunity is massive, but the AI opportunity, of course, is going to be even bigger than anybody has imagined. So we're looking at this through the lens of a natural progression. We started where telecom was the epicenter of technology. Now we're moving where AI and digital are the epicenter of technology. And by the way, the last two waves are overlapping. Digital has not ended with the advent of AI. Digital and AI continue to shape our day-to-day life, whether you are an individual or whether you are an enterprise or even government. And we're going to touch on government role in a second, because the government role in all this is phenomenally important. So what is digital infrastructure? Sorry, something. Okay. So digital infrastructure, what infrastructure typically had a very solid and well-defined meaning. This was formed towards the beginning of the last century. So this is railway, this is road, transportation networks, and so on. So this is the traditional concept of an infrastructure. But because now we're living in a digital world, we need an infrastructure that meets the digital demands of today's requirements. And essentially, there are three interconnected and related categories of infrastructure that fall under that term. You have mobile infrastructure, which is essentially the mobile towers. And mobile towers now have become so important that non-telcos are investing in developing mobile tower networks and offering the service to mobile operators. So tower infrastructure is an enabler within the mobile space. So that's a digital infrastructure piece that we need to be aware of. Then you have fixed line infrastructure, and the straightforward example is fiber networks connecting everyone. Of course, you have the legacy copper touching our homes and legacy buildings, but essentially more and more, all the new developments and all the compounds and new cities and so on are reliant on fiber because of the bandwidth requirement that a modern home and a modern business requires. So that's the second piece. And the third piece, which is going to be the bulk of the presentation today, is data centers. Now, data centers are the hubs of economic activity. This is where digital value is being created. And one cannot really stress or overstress the importance of a data center to a modern economy. The $14.5 trillion I referred to at the beginning of the session gets created primarily within data centers. And that's why governments, as well as institutional investors and all sorts of stakeholders, are focused more and more on data centers, especially now that we have AI requiring huge requirements on data center power, space, and so on, which we're going to clarify in a second. So the takeaway from this slide, digital infrastructure covers three main categories: mobile, fixed line, and data centers. And this is the view of the world that you need to look at, regardless of whether you're consuming a telecom service, an information service, a mobile device, fixed line device. It's essentially one of those three entities that actually is enabling you to access whatever it is you need to access to do your job, either at home or at work or any place. There is this unique quote online that data is the new oil. Everybody talks about this. I personally fail to determine who was the first one to issue this. But if we adopt this view of the world, that data is the new oil, then you have to actually accept the fact that data centers are the new oil refineries. Because within data centers, you have all the interconnection that happens between different platforms, and you have all the digital value creation that happens on these platforms and the access by consumers and businesses and so on. So it's not an exaggeration to say that data centers are truly the backbone of the digital economy. This one is a nice slide. You can have different versions of this online. I am using the one from Tom Travel. But essentially, what this slide is trying to communicate is how much value is being created on the internet in 1 minute. How many sort of interactions, how many posts, how many photos, and so on. There are many of these posters, but the staggering statistic about this is that all this happens within a data center. I don't know if you ordered Uber this morning or if you ordered pizza on Talabat or you ordered or watched a movie on Netflix. Whatever you did today between the moment you woke up in the morning until now, you must have interacted with the data center. You just do not think about it along these terms. If you order an Uber, that data is stored somewhere, and that somewhere is a data center. Same thing with Talabat, Netflix, and any other application you might use. And the same goes for if you use Google Maps, if you search for something on your desktop, that data sits somewhere. And that is an important fundamental concept that sometimes we miss. So on a daily basis, we interact with data centers not even on an hourly basis. On a minute by minute, you access data centers. And that means that somebody has to build it, somebody has to maintain it, somebody has to invest in the upgrades, and somebody has to actually provide power to it. And that puts into perspective the importance of data centers as the backbone of digital economy. Everything you do daily has to interact with the data center. This is a CIO slide, I call it. This is fundamentally what has happened to data centers' role in the IT ecosystem over the years. I'm not going to waste a lot of time about it, but you probably can relate to one or more of these stages because you probably have interacted with data centers in one capacity or another along this timeline. What we can agree on right now is that any enterprise, whether small or large, must have some sort of an interaction or a presence within the data center in order to function. Whether that organization needs to access financial platforms or needs to actually update a database or need to actually interact with customers, data centers are becoming fundamental, and they are becoming the true enabler of digital transformation. And the second point I want you to stress here is that data centers are no longer specialist functions, specialist establishments. Regular people, regardless of their interaction and regardless of their education, daily use data centers. They just do not understand necessarily every time they use it. But data centers have become so ubiquitous that we all, regardless of our education, function, seniority, age, deal with data centers on a daily basis, much like we deal with electricity stations when we use electricity at our homes or when we use sanitation services. We never think about these kinds of complex infrastructure pieces. We just use them. And the data center is becoming like that. You use it without actually thinking twice about where this data is coming from and who actually takes care of all the security and development and maintenance about it. This is a very nice slide. And this is outdated, I should tell you. This was issued December 2023. Based on data collected around November, December 2022. So by December this year, in about a matter of like 6 weeks, this is going to be outdated. And this is both good and bad. What this communicates is the collective concentration of data center markets around the world. Data centers are used, the definition of data centers or the unit of measurement is megawatts, essentially how much electricity they use. It's no longer square feet or square meters. People have actually accepted that megawatts is the proper indication of a data center energy consumption and power. So what you have in front of you is the collection of all the data center power by market. So you can see that the largest market in the world is Northern Virginia. That's roughly 2.5 gigawatts of capacity spread over all the data center there. You can look at Beijing in China as probably the second highest market, and you can looking at 1.8 gigawatts of capacity and so on. These are the top 50 markets globally. And as you can see, the global south, to use a Davos term, is poor in data centers. We do not have in the global south a lot of claim to being a leader or even a moderate-sized economy. And that's where governments should focus their attention, in my view, that this gap that is developing between the North and the South is no more evident than this digital infrastructure landscape. The North is rich not because they have more money, because they have more processing power and more server power and more data to play with. Whereas the global South is poor, not in human resources or not in natural resources, but we do not have the engines of digital economic activity. And that is a huge area of development I can tell you there is no shortage of capital in the South. There is no shortage of talent in the South, but we do not have coherent policies to attract these kinds of platforms, how to develop them, and how to retain the talent necessary to run them. So this slide is indicative of life in the 21st century. This is our modern reality, that the services and the applications that the platform we use are mostly housed somewhere in the North, and we as South or Southerners access them via long lines connecting to these hubs of economic activity. Now, over time, hopefully this will change because we will have our own infrastructure, and most of the countries in the South have plans to do so. Sorry. But until this happens, this picture is going to continue to haunt us as people living in the South and aspiring to have equal level of infrastructure development in our economies. This is another staggering statistic. Africa, Latin America, and India, these are huge economies. And while they present 44% of the global population, we only have 5% of the global data center capacity in those markets. What does that tell us? There is room for improvement. There is definitely room for improvement in investment in Africa and Latin America and India in order to actually develop data centers and the infrastructure that supports data centers, mainly power, and the connectivity ecosystem that actually allows people in these markets to access data centers. These are staggering statistics, but it's a starting point. I'm hopeful within 10 years, within our lifetime, we should be looking at a completely different picture. And I'm guessing the people in this call have a role to play in facilitating this transition. This is also a very interesting slide just to put what I just said into context. This is a very recent update by global consultancy firm Cushman & Wakefield. I think that I put the report myself on the Internet Masr WhatsApp group. If not, remind me, I'll put it again. And essentially what this says is, how do we compare in the emerging markets compared to the developed markets? So, and again, the metric here is megawatts. So on the y-axis or the vertical axis, you have countries or markets allocated as per their collective data center power in these markets. And on the vertical axis, you have the maturity of these markets, and on the horizontal axis, you have the total power for each market. So essentially, you can look at a market like Frankfurt to the upper right of your graph and see that this market is huge because they have nearly 2,000 megawatts or 2 gigawatts of capacity connected to it. So that's a very mature market. By comparison, a market like Milan is trying to catch up with the top four: Frankfurt, Dublin, Amsterdam, and Paris. In our case, in the emerging markets, you will find us towards the lower left corner of the graph. So we're in the emerging or developing kind of stage. You can see Cairo, Jeddah, Doha, and Reykjavik, Lagos, and so on. So upper from that, or the top of that, are the leading countries that we look at with envy and we try to mimic. Abu Dhabi has established itself as in a really enviable position. Johannesburg is also there. And Dubai is catching up. So the idea here is that to understand that different markets are falling at different stages of development based on economic policy, government awareness, investment capacity, and the amount of economic activity. But everybody is running in the same race. And some people are ahead, and some people are way ahead. Northern Virginia is plotted on this graph, not to scale. But just to give you an idea, mirroring what I just said about the slide 2 slides ago, that Northern Virginia remains the top global market, and Beijing is the second one. So everyone on the planet is running in the same race, and we're competing to try to develop our economies and do this digital transformation of our national infrastructure and national economic activity. Some numbers to put these into perspective, and these are staggering numbers as well. These are just four players. And this is only in 90 days. So essentially what this tells us is that those four players in front of us, Microsoft, Google, Amazon, and Oracle, spent, the actual number is $56.5 billion in 90 days. In Q2 this year, this is what these four companies alone spent on digital infrastructure, which essentially includes data centers, either for cloud or AI, as well as the power requirements to power this data center. And power is going to actually be a focus for us in just a couple of minutes. But just wrap your head around these numbers. These are just four companies on the planet spending roughly $55 billion every 90 days. And one of the things I keep mentioning whenever I have sessions or meetings, how much is your country, depending on who I'm talking to, is getting out of this. not necessarily Google or Amazon, but how much business or how much investment in your country is happening within digital infrastructure. So if you talk to somebody from Nigeria, Morocco, Kenya, South Africa, UAE, Saudi, Egypt, a typical question should be, how much business in terms of digital infrastructure investment is flowing to your economy, because that's indicator of how modern and how interesting your economy from the global perspective. I can't continue talking while ignoring AI, so might as well just talk about AI. The world is taken by this AI tsunami right now. Sorry. Okay, so the AI essentially has two stages or two. It's not born functional from day one. You have to actually train the AI system somewhere, and then comes the issue of unleashing that AI or connecting it to an enterprise data set to solve the problem. So generative AI is what we deal with right now. This is like ChatGPT and Gemini and Grok and so on. And these systems were not invented overnight. They were trained over many months and years. And once you have a system that is trained, then you can actually do something with that system. In our case, we use it on a daily basis to write articles or summarize videos and so on. But the big money is yet to emerge. The big money is in actually inference AI, where you actually take an AI system that has been trained on similar data sets to your company, and then connect your data set for your particular business to that engine and to ask it to solve problems. So imagine you're an airline and you want to actually optimize pricing of tickets. You cannot actually do that without the data set for your business being ready, and then connecting it to a system that has been trained on similar data sets for other airlines. So then they can actually crunch the numbers and answer your questions. And here there are two schools. Either you take the model to the data, or either you take the data to the model. I'm not going to actually waste a lot of time on that. But the point here is that generative AI is something that resembles the industrial revolution that happened when we invented the steam engine or electricity. And right now there is a ton of money, billions and billions of money going towards training of different kinds of models. The most exciting ones are, for example, in the pharmaceutical industry, training models like protein models and pharmaceutical models to predict the behavior of the human body in response to a particular drug and so on. So AI is going to shape all the investment in digital infrastructure because it's such a big thing compared to traditional, for example, cloud computing and so on. What happens, unfortunately, as a result of this is insane requirements on energy. Typical data center environments have the standard rating of what consumption of electricity happens within a rack. And typically in a data center for enterprise, similar to a bank or an airline, you typically have 6 kilowatts to 12 kilowatts of data consumption per rack. That's the energy consumption for a typical rack. And most of the data centers around you, either in Egypt or elsewhere around the Middle East or even Europe, fall within that category because the requirement was just simply hosting enterprise applications like Oracle or SAP and similar applications. Over time, what's happening is that you're actually moving toward the inference application, whereby you want to run AI localized to your data set. You're not going to use the public AI engines that we use as consumers. You want to have dedicated AI. And then you find that the data center requirements in terms of power, as well as cooling, go up dramatically. Now we're talking about 12 to 24 per rack, and a large organization would probably require tens of racks. Then you move into the cloud and the AI workloads domain, and you suddenly find yourself required to provide these data centers with more and more power and more cooling. This is where liquid cooling comes into the picture, and it's a complicated thing. But essentially, air cooling is not enough to cool these racks at full operation. So you need to provide them with some sort of plumbing so that heat exchange happens with liquids, essentially running water in pipes rather than typically air. And then you have the holy grail of the industry, which is these massive AI dedicated data centers that are populated by these massive servers with the NVIDIA chips that crunch numbers and do training and do inference at large scale. This is the hyperscaler model. This is the data centers for Tesla, for Google, for AWS and Amazon and so on, and Microsoft, of course. So what this shows us is that there is opportunities for investment, but there are also very challenging issues involved in this. Essentially, how you're going to actually provide the power or the electrical energy, and how actually going to actually provide connectivity and access in a secure way to these data centers. So that essentially puts us face to face with the energy transition requirement and the SDGs. There is a huge amount of work being done to make sure that whatever investments being made in data centers happen in a sustainable and environmentally friendly manner. Some countries are way ahead of others in that domain because they have a very progressive energy policy. Europe, for example, is stuck. Europe is in a big trouble concerning data center or large-scale data centers because there is a huge environmental block in Europe driving politics, and the environmental blocks in Europe do not think data centers are environmentally friendly necessarily, and they want to drive them out. And they think that data centers put unreasonable strain on the national grids and electricity. So that's why there are a lot of politics, which I'm going to explain in a second, involved in this energy policy kind of thing. Potentially, this can be an opportunity for some emerging markets to actually position themselves as good hosts for data center development, but it requires a lot of coordination and a lot of progressive policies. Just wanted to put this number in front of you. This is a very famous paper popularized by Standard & Chartered, and essentially says that if you can actually take the entire global electricity requirements and energy requirements and transfer them to renewable energy, it's going to cost you only 62 trillion. I know the number is laughable, but the staggering statistic, actually, the payback would be in 6 years. So imagine this, you're going to spend, of course, this is hypothetical, nobody's going to spend 62 trillion. But the idea is that you can save the world a lot by switching to renewable energy, simply because you're going to save yourself all the cost that is now currently being paid to do the decarbonization and the net zero carbon footprint and all the carbon neutral activities, the programs and voluntary carbon markets and the carbon offsets. This whole thing is $1 trillion business, and you can actually recover that in 6 mere years if you do the transition. What does that show is that there's a lot of promise if an economy like Egypt or Morocco or Kenya or UAE or Saudi commits itself to an aggressive sustainability objective, because number one, you're going to ensure that you meet the requirements of your digital infrastructure, but number two, you're going to save yourself a lot of money in terms of this decarbonization way. This is interesting because we're all here as individuals, but we're all here as well as business people. And maybe some of us are involved in government work as well. So what I'm going to try to do is to dissect the AI value stack, because AI now is top of mind for everyone. There are 4 ways or 4 layers of value creation within AI. And at each one, you can make money as an investor. So let's say you want to invest $10,000, $15,000. I'm going to tell you what people are doing with that kind of decision. But also this can drive economic policy at the government level. This can drive strategies at the company level, and it's going to become clear in a second. So the AI value stack has 4 layers. The first one is what we just spoke about, energy. As we agreed, these things are dinosaurs in their, so I should say dragons in their usage of energy. So you can say, okay, I'm going to invest in energy providers. I'm going to put my $10,000, $15,000 that I saved in companies, in the stock of companies that provide energy to data centers. As a country, you can say, you know what, I'm going to actually be the provider of energy. Morocco is doing a lot of that with the UK, by the way. Morocco has identified the UK data center market as a strategic opportunity. So Morocco is providing solar energy via cables to the UK so that the UK can run their massive data centers for AI using energy that was created in Morocco, and the distance is covered via an electricity cable. Similar dynamic, by the way, is happening copy-paste between Singapore and Australia. Singapore is developing something called the Sun Cable to Australia. That's 4,300 kilometers of cable just to get energy from Australia into Singapore, which is really poor in terms of solar energy because they don't have a lot of space. So the first layer of value creation in AI is to provide the green energy to actually meet that demand. The second layer, of course, comes the data center, which is building and developing and operating the data centers. You can do it for yourself, or you can host other people's data center. And again, putting the hat of the private investor, you can say, okay, I'm going to buy the stock of data center operators, companies like Equinix or Digital Realty or any other company that builds and maintains data centers. So that layer sits on top of the energy layer I just explained. So you need energy to power up the data center. So now we get an understanding of the layer, how the layers are interconnected and how they actually, how value flows through them. The third layer is, of course, the chips. Everybody talks about NVIDIA. It's easy to forget that Google also has a number of chips like the TPUs, and Tesla actually designs a number of chips, and there are others in this race as well. So in order to run an AI model, you need to run it on chips, dedicated GPUs or TPUs. These chips consume a lot of energy, but they are also placed in a data center. So suddenly you get an idea about the relationship and the value creation across the value chain within AI. And the fourth one is the AI system. This is ChatGPT, this is Claude, Grok, Gemini, whatever it is you're using.
Recording stopped.
And of course, you have a number of specialist AI systems, as we said, for the pharmaceutical industry, for industrial applications, for weather prediction, and so on. So if you think about it, AI does not happen in vacuum. AI happens, it's like a value chain or an ecosystem, and you have various layers within that ecosystem that actually deliver value to the next layer higher up. And as an investor,
recording in progress,
or as a government, or as an enterprise, you can make money in any of those four layers. Some countries decided that they're going to be power sources for others. Other countries decided that they're going to host data centers. Other countries like China or the US decided they're going to produce the chips. And other countries decided that we can actually manufacture these or program these AI systems. So this is a driver for economic policy at the national level, but also a determinant for corporate strategy at the corporate level. And you can figure out which is which depending on your mandate and your outlook. This is an ugly slide. Let me be the first one to confess. But the idea here is to just give you an idea. When people talk about infrastructure within the AI data center, essentially value creation happens either within the rack or outside the rack. Within the rack happens to be where the servers and the processors and the memory and the components and the semiconductor elements interact. So that's the top layer part of the graph, the inside the rack. And these are the companies that are creating value within this space, either manufacturing or providing interconnection or providing connectivity and so on. If you leave the rack, you are within the data center environment, and within the data center environment, you need a lot of companies working together to make value creation possible. This is the cooling part, this is the power management, this is the security, and this is testing, measurement, power generation, and so on. So essentially, you can look at a data center as a set of really complex interconnected components, and each one of those verticals, and again, this slide is not exhaustive, I have not put everything there, but to just give you a flavor that these ecosystems are very complicated and they require a lot of enabling factors for this data center to actually deliver value. So a lot goes into building such a data center, especially an AI data center, which is a huge undertaking. But other people are doing it. Definitely emerging markets are focused on it. So if we're putting on the hat of Egyptians, with respect, of course, to any other economy, we need to actually get our act together and start thinking about how these data center infrastructure, especially AI infrastructure, can find a home in Egypt and how they can solve Egyptian economic problems, because there is a lot of promise in that area. I'm almost done with my presentation. I'm just going to touch on challenges, and my objective here is to open the door for future sessions to address these specific challenges. So the first challenge is of course power. It does not come as a surprise. We spent a considerable time today talking about SDGs and sustainability and power. Power is a challenge, especially in places like Europe and even the Middle East as well. If you have power resources, especially renewable power resources, then consider yourself lucky, because that is a key enabler for digital infrastructure investments in your economy. So power, there is a lot of issues about power generation, transmission, national grids, modernization, and the whole energy transition discussion, which is sweeping the world. So you cannot have an intelligent discussion about digital infrastructure without addressing the power piece. The second piece is politics. There is a lot of politics involved. Some of those politics are national, some of them are international. National meaning that within every country, there are people who are against investment in data centers, because let's face it, data centers do not employ a lot of people. So in terms of employment, job creation, it's not really a target industry for job creation. So a lot of people have a very strong position against these kinds of facilities. Others, on the other hand, see the economic value in terms of billions being added to the GDP and are proposing more investments. If you can look at Europe, you'll see Ireland, for example, has a lot of debate about this for the past 3-4 years. Singapore is a nice example, and so on. There is also an international aspect to this because not every country will be able to attract the investments necessary to sustain its economic digital activity. That essentially means that country A, if they manage to accumulate resources within data centers, they will be able to serve neighboring markets. The best example I can give you is Saudi. I'm going to talk about Saudi in a second. But if you look at what Saudi and UAE are doing, it's exactly that. They're playing a very geopolitical game whereby the accumulation of digital infrastructure within their markets as a result of favorable policies will enable these markets to serve other less developed markets around them. And in that sense, you become a provider of economic value creation to others using the infrastructure housed within your national borders. So there is a lot of politics in these kinds of investments, economic policy, investment promotion. There's a lot of security as well, which is ugly, but necessary, unfortunately, in order to have a meaningful backbone for digital activity. The third component is people. This part is about the skills. I can tell you with confidence that not a single country in the world has enough skilled people to actually develop these kinds of projects and infrastructure. There is a huge amount of effort needed to actually do retraining, reskilling, and attracting the right talent into these sectors: AI development, program management, strategy, marketing, sales, as well as the whole piece about security and economic policy. So people in itself is a challenge because this caught the world by surprise. So everybody now is running around trying to figure out, do I have enough people? The answer is no, probably. Okay, how can I actually address this? How can I actually bridge this gap, and so on? And again, as an Egyptian talking to a group of international audience, but also Egyptians, I can tell you that Egyptians are some of the most sought after qualified professionals in this space. And a lot of the activity that's happening around us in the region is being developed, planned, and implemented by Egyptian professionals. So at least we have the talent. We just need to figure out the talent, how to actually attract the talent back home to actually add value to the Egyptian economy. But definitely they're doing great work in a lot of the emerging market that I've looked at. And the final piece is the planet piece, the sustainability. The whole point about renewable energy, sustainability, decarbonization, how to ensure that whatever happens within the data center and digital infrastructure investment does not come at the expense of the gains that have been achieved within the national agenda for sustainability and renewable energy development. I can't tell you how this is now being looked at with increased scrutiny, especially in markets that have achieved a lot in their environmental sustainability and strategic planning. So the 4 pieces, which happen to be 4 Ps, by the way, the 4 pieces are interconnected, they feed each other, and there is relations between, for example, politics and sustainability plans, between people and politics, and so on. So each one of those can be a session in itself, and I'm looking forward to hearing more and more about these as we go through the digital infrastructure series developed by the Internet Society of Egypt chapter. I just want to touch on Saudi. I'm almost done. Saudi is a very nice digital infrastructure success story. The most promising part about this Cinderella story is that none of this existed. None of the achievements we look at Saudi right now existed 7 years ago. In just 7 years, Saudi managed to establish itself as a leading market in the region for digital infrastructure. This touches cloud as well as AI now. And the amount of investment in Saudi is really interesting, and it gives us all hope that if this can be done in 7 years, then definitely a country like Egypt or Morocco or Kenya and Nigeria definitely can do their own success story. I'm just going to highlight something in terms of government planning. The Vision 2030 for Saudi is published online, and you can take a look at it. It's transparently tracked, and it's a driving force behind a lot of the decisions being done in Saudi. What's interesting for us as digital architects in this space is that the 2030 vision identifies specific targets for digital infrastructure. So essentially, you have these numbers baked into the plan. If you look at the plan, they target 1,300 megawatts of data center capacity by 2030. That number probably is a stretch target, probably is not going to be achieved given that right now they're around 300 something. So there's not enough time to actually grow this fivefold or 4.5 times. But the fact that the economic policymakers have identified digital infrastructure as a key enabler for digital value creation is something that gives us all hope that we can look at something like this and adopt to our economies, whether you are in Africa or in Asia. And the second point is the FDI, the investment. They're targeting $18 billion in investment to actually meet the 1,300 megawatts of digital infrastructure. So the point here is that similar to agricultural policy or export policy, you have now the makings of a digital infrastructure policy, and markets like Saudi Arabia are saying, you know what, this is too important not to put under the mandate of a vision document. And this is being tracked and reported on. And I can tell you only good things about what's happening in Saudi. And of course, UAE is doing a lot of great work, and other markets, especially in Africa, South Africa is doing similar work. Just wanted to highlight the fact that this is now becoming part of the economic planning toolkit for any finance ministry, any treasury ministry, and any economic planners across the region. I'm going to close my presentation with just to contrast these two terms because they sometimes are used interchangeably. Digital infrastructure is what we spoke about now, the mobile piece, the fixed line piece, as well as the data center piece, whether cloud or AI. DPI touches on how the government in the digital domain conducts its business with its citizens. So this is identity management, payment systems, as well as a ton of other systems that actually govern the relationship between the digital government and the digital citizen in order to make sure that the government continues to do its job in the digital domain, and that we as citizens can access what we need from government service in the digital capacity. Of course, security is a big part of this, as well as identity management and so on. So DPI is probably related to DI because it uses some of the infrastructure we spoke about. You need data centers as well, and you need fixed line interconnection, and you need mobile apps, but it's not the same. So there is a kind of intersection in the middle, but these are different kind of domains of research and development. This is my last slide, and I just wanted to tease you with it. There is this debate in the industry about sovereign AI, and this quote comes from the World Government Summit earlier this year in February. And sovereign AI essentially deals with the fact that you cannot, as an economy, rely on models that have been developed elsewhere. Sooner or later, you have to develop to face the fact that you need your own sovereign AI based on your own culture, your own systems, your own norms. So that, and I'm not meaning this from the security perspective. That's not about control. This is about having meaningful results. If I use ChatGPT today, ChatGPT was not trained on my literature, not on my data, not on my current social norms and so on. So the results I'm getting from ChatGPT are influenced by the data set that has been used to develop ChatGPT. So sooner or later, you're going to actually, as a country, as an economy, face the fact that you will need your own sovereign AI. UAE is doing a lot of activity in that domain as well. I should commend them on that. And every country on the planet will end up with its own kind of model to actually serve its citizens. But that's an area for research and an area for debate as we go forward. I'm done with my session. Hopefully this was not too boring. And back to Mariam, I guess, and Q&A if we have people who are interested.
Thank you very much. It was amazing, triggering, mind-blowing, and I love how you bring resources, different resources to the talk. And you always do this on the WhatsApp group of Internet Masri. You always bring in your knowledge and diverse reports and diverse experiences to share. So Dr. Ahmed Mukhlis, please feel free to your comment.
Yeah, Ahmed, very insightful report and presentation. As usual, you are an expert matter. Very proud of him as a colleague and as an expert matter in the field of data centers. I have two questions to Ahmed. The first one is around investments. We know from the valuation game that, private equity and, financial institutions are a little bit, far from investing more in AI powered data centers because of, potential valuations going lower than expected before. And they prefer, software as a services in order to invest. Valuation before used to be around maybe 20 to 22x in DIs. Now the SaaS models are providing 25 to 28x. So you will find the shift from the mindset of private equity financial institution to invest more in AI-powered data center, which is a very capex intense, average break point 7 to 8 years. So how we are going to overcome that challenge? That's the first question. The second question is around Africa. To be honest, the benchmark compared to Egypt, we are far off from the benchmark compared to South Africa. South Africa standalone, there is one operator called Terco, who has almost 130 megawatt of capacity, which is acquired by Digital Reality. So what is needed from Egypt to the likes of Digital Reality Econex to come and invest in Egypt? Thank you.
Okay, so on the first question about multiples, the whole AI data center is less than 24 months old. This is a very new beast. So nobody has a clear game plan as far as the actual return on investment. And it differs if you are a hyperscaler than if you are a national operator or an African operator, for example, operating within a particular market or a continent. What people are confident about right now is that adoption of AI is only going to accelerate. So whatever demand forecast we're looking at right now that flows into the business planning and the CapEx projections, this is only going to accelerate. So people are investing with confidence that the multiples will happen at a reasonable level, but there is no certainty. I'll agree with you. There is no certainty right now as to when and exactly how large or how long is the payback period. But what gives people confidence is that AI feeds itself. So the first generation of AI is going to actually make the second generation more faster to market and more robust. And that actually will facilitate the third generation and so on. And that would only help to actually accelerate the return on initial investment, because essentially the bulk of the investment, if you do it right, is going to be absorbed in the first pass. And then what happens later on is more advanced chips and more advanced systems and more complicated neural networks. So it's similar to building a submarine cable network, for example. The bulk of the investment goes into laying the cable, and then over time you change the terminal equipment in the landing stations, and you're able to extract more value from the initial backbone that you laid 5, 10, 15 years ago. It's a similar kind of dynamic. So 7, 8, 10 years will probably materialize initially, but then you're going to be looking at 5 years and 4 years, depending on the scope. And of course, depending on the application, because some of these vertical AI systems, like the pharmaceutical industry, are going to be very specialized, that they can actually achieve return rather quicker because they do not require large-scale adoption. They require vertical industry adoption. So that in itself gives hope that some of the investments in these AI-specific data centers will accelerate return to investors in a fashion that is not entirely clear today, but definitely one can relate to it. The second point about the policy, Egypt can do a lot. We do not identify digital infrastructure today as a distinct industry. We still are confused as a community, as a regulator, as government economic planners between telecom and other related industries. We do not have a focus per se on digital infrastructure. That goes into the kind of incentives we offer to international investors, that goes into the kind of licenses that's available to actually develop these kinds of infrastructure, that goes into our into our energy policy. You do not have a lot of focus on energy providers specifically delivering energy to the data center operators. So there's a lot of coordination that's needed. What I can tell you with a lot of happiness is that Egypt ranks globally among the top in terms of renewable energy resources. So that gives us hope that in terms of energy, we're not going to be squeezed like European countries are squeezed right now. However, that leaves a lot of coordination between various government entities to actually create the incentives for the investment to flow in the country. Second point is to figure out whether we want to actually play a regional role rather than a national role. By that, I'm referring to the example of Saudi I mentioned 10 minutes ago, whereby a lot of the investments that are being put in place are being done with an eye towards serving other markets. So Egypt can potentially play a similar role. I'm not so sure that the economic policy developers in Egypt are adopting this view, but it's definitely an area of debate because we can play a role, especially within the African subcontinent. Countries related to us, Chad, Sudan, South Sudan, Tunisia, Libya, and so on. There is a lot of potential in the economic digital value creation in Africa, and Egypt potentially can play a big role there if we get our policy right, if we can align our ducks in a row, to use a bowling term. The sky is the limit. So these 2 points need to be addressed: coordination between the government and figuring out whether you want to be a national player or a regional player. And you definitely can do a lot of trade with Europe in that respect, because Europe is not really favorable in terms of these large-scale investments. Maybe you can play a role there, but it also requires a lot of coordination with the EU. So these areas are definitely areas of debate and development for Egypt.
Thank you very much, Ahmed.
I can ask a couple of questions, if you don't
Please.
mind. They might sound simple or naive, but I'm building on what you and Dr. Mokhlis were saying. So you both talk about sovereignty, AI sovereignty. So I don't mean to talk politics in any way, but it was in the news publicly that the US officially wants to limit the amount of AI technology coming into, I don't know, different parts of the world. So this means that somebody here is in control and limiting what others have access to. Can some nations like Egypt, for example, or South Africa you've mentioned, build their own AI systems or ecosystems on their own? Is it doable and worth it? And this is something. The second thing is I wanted to look at is that big countries like Egypt and India, we have massive amounts of data, unused data. Maybe India's data is more clean, structured. Ours still not yet, I assume, if you allow me to say. So what can we do also to ensure that we make use of our data for ourselves and for others? Last but not least, you are an expert in reading reports. You have been supporting us in Internet Master with summarizing and analyzing many reports. How do you see the rank of Egypt? And since Egypt ranked up, so how and why in the AI indices? Thank you.
Okay, so the first question was, can countries like Egypt or Nigeria or Kenya or other countries develop their own AI systems? And the answer is yes. AI systems are essentially neural networks in terms of computer science architecture, and the technology behind it is fairly understood. Of course, you require to develop the neural networks, and you require actually to identify the rules through which the neural network is going to actually learn from the data sets that you're going to feed it. So the challenge is not developing the AI systems. Of course, developing something like ChatGPT or Grok or Gemini is a massive undertaking requiring a large investment. But in terms of something for educational purposes, something at the university level, something even at the government level, this is definitely doable. What's going to be a little bit problematic to get competition in is the chips, the silicon, the processors that run the models. And you're right, the US almost has a monopoly on that, because whether it's the Tensor chips by Google or the Tesla chips or the NVIDIA chips or the AMD chips, these are all American companies at the end of the day. We don't have a lot of competition in terms of processors. The hope is that within the next, let's say, 24 to 30 months, you're going to have chips manufactured by countries like China or Korea that can actually not necessarily compete, but at least offer an alternative for emerging economies to use in their training of data sets, AI data sets. So right now, you're stuck in a situation where the technology is primarily American, and they can punish you if you sort of adopt a policy that's not to their liking. They can deny you chips. They're doing the same, by the way, very aggressively with China. China has a very hard time getting any chips and so on. So that's the nature of the global sort of political system that we live in, and technology is just a victim of that. But over time, this is going to change, and we can benefit from that. But there is nothing preventing us from trying to actually develop the software and the neural networks to actually address specific areas of our economic activity. And over time, we're going to get access to these advanced chips. The second question is about data. You mentioned the fact that India and Egypt has a lot of data, and how can you actually make use of that? Well, the problem with these economies, and Egypt has definitely gone a long way on that track, is the sort of the quality of the data, the integrity of the data. Data needs to be cleaned up. Data need to be available in a format that is interchangeable across systems, not locked in a database that's developed in 1985, for example, and so on. So there is a lot of activity that needs to be done before the data becomes addressable and accessible to an AI system. So that unfortunately has to happen outside the AI development lifecycle. You need to have these databases, you need to have these systems, and then the data feeds can feed into the AI for training. And the good thing is that because you have a ton of data across various systems, training of AI systems, once these data systems are connected, is going to be relatively rapid, because you have a lot of systems, but the systems has to actually be integrated according to some way, some security measure, some sort of access protocol that allows the Ministry of Agriculture data, the Ministry of Interior data, the Ministry of Youth data to be sort of interconnected. And then we have these massive models that actually can track a lot and enable a lot of activity value creation. The third, remind me of the third part of the question, please.
It was about that you analyze well reports.
Yeah, Egypt standing. Yeah, I remember. Well, it's a mixed bag. Egypt ranks fairly well in terms of government readiness. There is a famous report by Oxford Analytics that ranks Egypt among the top in the African continent, I think number 4 or 3 or something in terms of government readiness. That's because the government has actually put in place an AI roadmap, and there is a national strategy and so on. Where we rank globally poor is, surprise, surprise, infrastructure. We do not have a lot of credible infrastructure according to the international standards that can actually enable AI systems to run locally at this point in time. So we rank poorly on that. We also do not rank highly in terms of the skill set, human capital. We don't have a lot of identifiable experts in the AI domain. We do have a few, of course, but not at the scale that can support an economy of 150 million people. So we do not rank, and that's probably going to be a matter of time, because before colleges and universities start actually integrating AI into their curriculums. You have people who are graduates of AI from universities and so on. So over the next 2-3 years, you're going to have a cadre of people graduating within a specialization of AI. So the human capital or skill gap is going to be taken care of, hopefully, relatively quickly. The infrastructure piece is a vexing one, and we do need FDI. We need foreign direct investment. We need private sector to actually step in and spend billions and billions of dollars trying to develop these systems, because that's going to be beneficial not only to the investors, but also to the government and universities and the economy at large. So infrastructure remains a tricky point. Any benchmarking done against Kenya, Nigeria, Morocco, South Africa, UAE, Saudi, and so on, will show that there is a significant gap between those economies and Egypt. And that comes down to FDI not flowing in time to digital infrastructure investments. So hopefully the government will catch up and provide incentives, back to my answer to Ahmed Mukhlis's question, that actually going to incentivize foreign investors, either hyperscalers or other smaller players, to come in and invest and actually develop these infrastructure. In terms of policy, as I said, the policy is there. There is definitely awareness at the government level, but it needs to be translated into tangible investments and tangible sort of projects on the ground, so that we can all run these systems and start training especially vertical AI systems in Egypt.
Thank you. Roa Deep from ISOC Lebanon, you were saying something in the chat. Would you like to contribute?
I think Ahmed has already touched on that point, but he discussed part of the value chain or production chain of AI, microchips were he talked about microchips, and under the new US rule of China +1 strategy, China is no longer allowed to build or create AI microchips. So it's usually a US ally that is only allowed to create it in the Asian countries. So so this is why, like, you now have a restriction or a gap, a technology gap or a wide technology gap when it comes to technology. So the new phase of the new world technology-wise is now restricted within the hands of few economies. So it's not it's no longer globally available for all people. So it's a strategic tool that is being restricted within a country or within a certain access, let's say.
That is correct, unfortunately, but my submission to the distinguished participants is that this is not going to last indefinitely. Sooner or later, somebody is going to actually figure out a way to provide not necessarily something at the level of NVIDIA, because that took them like 30 years to develop. But you definitely have enough demand in the global economy and enough incentive for companies and countries to invest R&D. So in the next, let's say, 3-4 years, you're going to have definitely competition in terms of GPUs. Right now, the US is betting that nobody's going to be able to crack this code and nobody's going to be able to put any meaningful competition in terms of chips in the market. But it's technology at the end of the day. And if we have learned anything that is far-fetched will eventually become a reality. So the Koreans are spending a lot of money on this, South Korea in particular. BRICS, by the way, do not put it beyond BRICS, because BRICS is a collection of really progressive countries, and collectively they represent a sizable percent of the global economy in terms of trade and services. So BRICS will definitely put together the brain power in China, in Russia, and Brazil, and South Africa, and so on. You can actually figure out that it's not going to be long before a company gets some funding from BRICS countries and develops something. And so on. Something's going to give. I would be lying to tell you today if I have visibility into that. But I have confidence that eventually this monopoly by the US is not going to last. And too much is riding on this AI to let one country dictate the future.
Thank you. Dr. Mokhlis, please.
I think Ahmed triggered my attention on who owned the value chain. And then we see some developed models in the GCC like the UAE, by the likes of the MAC and the Amar, building data centers out of Saudi, out of that huge potential for the vision of 2030. So what is required, in Egypt for a tier 1 real estate providers, like, the likes of Hassan Al-Ami, ISOC and Co, to come with an understanding of the component of that ecosystem in order to start investing in it, especially if you see the real estate now booming in Egypt. Maybe it's a bubble for a time being, but at least they have the liquidity to build data centers. So what incentives, what kind of understanding they need to have in order to tap into that horizon?
Okay. Well, first of all, thank you for highlighting the fact that data centers at the end of the day is an asset class within the real estate sector. That part is sometimes misunderstood, and as a result, people fail to give adequate attention to the real estate aspect of data center development. You're right, we have a lot of really reputable real estate developers in Egypt, tycoons, if I say, really big companies, but none of them has identified data centers as an asset class within real estate. They're still focused on commercial, developing malls and or administrative business towers and so on, or of course the residential sector and the mixed use where you have, entertainment and so on. So number one, to answer your question, what is required is some sort of awareness that this asset class provides a fantastic return. And let me tell you why it provides a fantastic return: because of the power density. If you take a data center, the size of which is 10,000 meters, and you run it today to hot cloud, your typical rack consumes 25 kilowatts. Then over time, if you migrate to AI, the same data center, the same space, 10,000 square meters, all of a sudden you can put racks there that consume 100 kilowatts. And then in the next generation, consuming 250 and 300 kilowatts. So what's happening is that you're getting more and more value from the same square meters. And from a real estate perspective, that's fantastic, because you do not get the same kind of utility from, if you allocate the 10,000 square meters to a mall, for example, you can only sell 100 shops in that mall, or 80 shops, and that's it. Shops can rotate in and out, but you cannot create more value from the square meter. Whereas in a data center, because you keep upgrading the power requirements of a particular cabinet, and the cabinet is sitting in the same physical space, the return on investment from that real estate asset class is fantastic. So number one is awareness. Real estate companies in Egypt need to actually introduce this new asset class to their portfolio. Number two, the energy piece continues to be challenging. Even if a real estate developer identifies the asset class as worthy of investment and they can get funding, and I can tell you with confidence that there is a lot of funding available for digital infrastructure around the region, including international agencies. But the thing is that energy, especially in a country like Egypt, remember, up until a few months back, we had rolling blackouts where every part of Cairo had a table whereby you lose power for 2 hours, 3 hours a day in order to make sure that we meet the national quota and stay below the ceiling for LNG to run the power generation plants. So energy continues to be a challenge in a country like Egypt, and the real estate developer in this case has to get support from either the government or, which is the more promising aspect, a private energy generation companies, mainly solar or wind operators, who can actually feed the appetite for the data center. And until you have a clarity as to how that mechanism works, what rate should power be sold at, and what's an acceptable transmission rate for the national grid between the places of generation and the places for consumption, that piece will always be vague. Somebody has to actually identify this and clarify that kind of economic value exchange. And the third piece is the government incentives. If I'm going to build a data center today, how the government is going to treat me from a tax perspective, for example. Are they going to treat me like I'm opening a fast food restaurant or a textile factory? What kind of incentive, especially if you play the game of regional provider? So that means that you're going to be actually hosting someone else's data, providing them with storage and processing. So essentially become an exporter. Will the government provide such a digital export? Will the government actually provide incentive for me to spend as a real estate developer capex in developing these cross-border facilities so that I can take business from Sudan, Libya, Tunisia, Guinea, and so on? So that piece is also not clear in terms of a data center investment incentive. So I can tell you these three things are required before you have a vibrant data center portfolio in Egypt. Luckily, with time, we'll pick up what other countries have made. And luckily, the availability of capital will be a forward force in this race. But we need to get our act together as a community. The industry needs to speak, the government needs to listen, and we all need to sit around the table and have a coherent strategy about what Egypt can provide and how can actually capitalize on this massive opportunity regionally in a way that actually not only meets the requirements of the national economy, but positions Egypt as an economic engine for regional services across the Mediterranean and North Africa or Africa at large.
Great. Any more comments or questions? I think we had a very interesting discussion. We thank you very much for the valuable information and for keeping us uptight and informed and exciting us all the way through. I think everybody was enjoying every moment of the presentation and the talk. Thank you for the discussion. Thank you for the wealth of knowledge. And I invite you all to participate in this series. I think we can build it together. So whether you are a member of Internet Masr or from the global ISOC community or friends of Internet Masr and our community, please reach out to us. We're building this series. We're going to have 4 or 5 sessions about digital infrastructure, and we'll be happy to integrate any of your ideas. So reach out to us. And thank you very much, Engineer Ahmed, for this amazing presentation. And thank you all for your time. More to come. Bye.
Bye-bye. Ciao, ciao.
Bye. Ciao.
Thank you.
Thank you.